Hey everyone! In today's video, I'm going to combine our skills of knowing how to use the distributive property, knowing how to solve one-step problems, and knowing how to solve two-step problems. So we're going to combine those three skills of my past videos into this skill, and this video is going to address solving multi-step problems. So this means problems where you're going to do more than just two steps, and there's not a specific number of steps that you're going to do. You just have to continue doing these steps until you have the variable all by itself. There's just a couple things that I want to discuss before we get started on some examples. Before we get started on solving the problems, I want to go over and discuss the three different types of solutions that you could come across. So the first type is what we had when we were solving for one and two-step equations, is that you'll have a variable equal to a number. This is the one solution. So x equals 5, it's going to have one solution. You could end up with an answer at the very end where 4 equals 4, and you're like, oh no, something is wrong, this can't be right. If you have 4 equals 4 or variable equals a variable, it's fine because it's true. 4 does equal 4. X does equal X. Y equals Y. This is a true statement. So what this means is you're going to have all real solutions. So there is more than one right solution for this problem. And the final solution that you should look out for is when you have something like -3 equals 10. Okay, this is not true. I know that this -3 does not equal 10. So if you end up with something like this, odds are there is no solution to that equation. So these are the three types of answers that we are going to be looking for today, and here is what they mean. So I am expecting that when you solve a problem that you are able to tell me whether or not there's all real solutions, no solutions, or if there's that one solution, and then tell me what that one solution is. For my first example, do not be intimidated. I know it looks long, but I also know that you have the skills to solve this equation. Notice our variable is x. There are two of them, so that's something that's a little different, but don't worry, we'll get through it. Now, what we need to do is get x all by itself. The first thing that I see that I need to take care of are these parentheses. I see that there is a number on the outside of the parentheses. This makes me think of the distributive property. So that's what I'm going to do. I'm going to go ahead and I'm going to rewrite this equation by using the distributive property. Distributive property, distribute the outside number to the inside. Do my little arches. 6 times x is 6x. 6 times -3 is -18. Bring down the plus 10. I haven't touched that yet. Then I have 2 times 3x, 2 times -4, 6x minus 8. Now, what I need to do is look at this problem and decide what are the like terms, what needs to be combined first. Just like in the two-step equations, we need to combine the constants first. So I notice on this side, there's two constants. I'm gonna go ahead and combine those first. 6x minus 8, so the minus 18, -18 plus 10 gives me a -8, equals 6x minus 8. Notice, 6x minus 8 equals 6x minus 8. Does that seem similar to the solutions I showed you in the beginning, where you have the same thing on both sides? If you want, you can continue to solve for x, but if you already notice I have the same thing on both sides, you know that the answer to this problem will be all real solutions. For my second example, I'm going to start it the same way I did the first one, and I'm going to take care of these parentheses by distributing. So I'm going to distribute this 8 to the 4 and to the -2x. So that gives me 32 minus 16x. I'm going to bring down my equal sign. I'm going to distribute the 4 to the 3 and to the -5x. So that's going to give me a 12 minus 20x. Then I'm going to bring down this plus 4x. Because I haven't done anything with it, I just keep bringing everything down. so I don't forget about it. Now, if I look on this side, can't simplify that any further. These are not like terms. This one has an x, this one doesn't. I go over here. Okay, I see this one has an x, this one has an x. I am going to go ahead and simplify this side to 12, because I didn't touch the 12. Negative 20 plus 4 gives me a negative 16x. And then I'm going to bring down the numbers that I haven't used on this side yet. Oh, negative 16x on both sides. Does that mean all real solutions? No, it doesn't, because they're not exactly the same. There's a 32 over here and a 12 over here. We have to keep going. So the next thing that I want to do is I'm going to bring the 16x over to the other side and combine it with the other 16x. So I'm going to say plus 16x. I'm adding 16x because I was subtracting. If you want to move something to the other side of the equation, you move it with the opposite operation. So I'm going to add 16x to the other side. Negative 16x plus 16x gives me 0, so they cancel out. Negative 16x plus 16x gives me 0, so they cancel out. All I'm left with on this side is 32, and all I'm left with on this side is 12. 32 equals 12. I cannot do anything else really with this problem. What you will notice is that this is like that third solution that I showed you in the beginning of the video. This is not true. So your answer for this one would be no solution, because you ended up with a statement that is not true. I want to do one more quick example with you. I have 15 times 20 plus d equals 420. The first thing that I'm going to do is take care of my parentheses by using the distributive property. So I am going to take the 15 and distribute it to the 20 and distribute it to d. So I end up with 15 times 20 is 300. 15 times d is 15d equals 420. I'm gonna bring that 420 down just because I haven't touched it yet. Now, this looks a lot like the two-step equations that we have already solved. We have those skills, we know how to handle those. So reach back in your memory and you find that you need to combine the constants first. So 300 and 420. I'm going to move the 300 because it's closest to the variable and I want to get it away from the variable. So to move it, I'm going to say minus 300. It's a positive 300, so do the opposite and I say minus or negative 300. What I do to one side, I have to do the other to keep the balance of the equation. So that cancels out. I'm left with 15d, bring down my equal sign, and then 420 minus 300 is 120. My variable is still not alone. 15 times d equals 120. Since it's multiplication, in order to move the 15 and get rid of it, I'm going to divide by 15. If I divide by 15 on this side, I have to divide by 15 on the other side. These 15s cancel out. I'm left with d. 120 divided by 15, I'm left with 8. So d equals 8. This equation only had one solution that will work, and that solution is 8. I gave you 3 examples on how to solve multi-step equations. Now keep in mind, take care of those parentheses first by using the distributive property. Then start combining your like terms. If you want to move something to the other side of the equation, you're going to need to use the opposite operation. So if it was that positive 300, I subtracted it. That's using the opposite operation. Then just keep in mind those 3 types of solutions. You can either end up with one number in the end, you could have all real solutions, or you could have no solutions at all for that equation. It's up to you to figure out which one of those 3 solutions it's going to be. Good luck!